Next, we're going to find a way of solving equations that can be in quadratic form. An equation is in quadratic form if it can be written as au squared plus bu plus c equals 0, where a is not 0 and u is some algebraic expression. It's not just one letter. Now, equations in quadratic type can be solved by substituting. We'll substitute a single variable for a more complicated expression, and then we have to remember to finish by solving for the original variable. Solve this equation. First thing we're going to need to do is get it in form equal to 0. So we'll get x to the fourth minus 7x squared plus 10 equals 0. Now I'm going to substitute. I'm going to say u is going to equal x squared. That means u squared equals x to the fourth. So I'll put u squared minus 7u plus 10 equals 0. We know how to solve this. It will be u minus 5 times u minus 2 equals 0. So u equals 5 and u equals 2. However, now we have to go back to this. U equals x squared. So x squared equals 5 and x equals plus or minus the square root of 5. That's one pair of solutions. And then on the other one, x squared equals 2. So x equals plus or minus the square root of 2. Don't forget to go back and solve for the x's. Trying another equation. We've got x to the fourth and x squared. Let's do that same thing again. So we'll get u equals x squared, so that means u squared equals x to the fourth. So I'll have 18 u squared minus 29 u plus 3 equals 0. Let's try 9u and 2u. Signs are both negative. Make this 3 and 1. Negative 2u, negative 27u. That will give me my negative 29. So 9u equals 1 and u equals 1/9. 2u equals 3 and u equals 3/2. Now I have to go back to this and say x squared equals 1/9. So x equals plus or minus 1/3, since the square root of 1/9 is 1/3. And here x squared will equal 3/2. So x will equal the square root of 3/2, but I'll need to rationalize that denominator by multiplying by the square root of 2. This is a case where we have to rationalize, and of course it's plus or minus. So x equals plus or minus the square root of 6/2. Oh, this is a rather complicated form, but notice I have a b minus 5 over 6 squared and a b minus 5 over 6. So let's let u equal b minus 5 over 6. So that means u squared is b minus 5 over 6 squared. So I have u squared minus u minus 6 equals 0. So u minus 3 times u plus 2 will factor. Negative 3 and positive 2 will give me negative 1. So u equals 3 and u equals negative 2. But now I need to substitute back in here. So b minus 5 over 6 equals 3. b minus 5 equals 18. And b equals 23. And b minus 5 over 6 equals negative 2. So b minus 5 equals negative 12. And b equals negative 7. Well, here I've got some negative exponents, and I could just make this 1 over x squared. But I think what I'm going to do is I'm going to use a u substitution again. U equals x to the negative 1. So u squared equals x to the negative 2. So now I can have 15u squared minus 4u minus 3 equals 0, getting it equal to 0. I'm going to try 5u and 3u. Well, if I made this 3 and 1, negative 9 and positive 5 would give me the negative 4. So u equals 3/5 and u equals negative 1/3. But that's x to the negative 1 equals 3/5. So the reciprocal, x equals 5/3. And x to the negative 1 equals negative 1/3. The reciprocal, x equals negative 3. Oh, 1/2 is 1/4 raised to the squared power. So u can be x minus 3 to the 1/4. So u squared is x minus 3 to the 1/2. So I have u squared minus 6u plus 8 equals 0. U minus 4 times u minus 2 equals 0. U equals 4. U equals 2. But u is really this. So I have u minus 3 to the 1/4 equals 4. Oh, how about if I take each of these to the 4th power? So I'll get x minus 3 equals 4 to the 4th. So x minus 3 equals 256, and x equals 259. And for the other answer, I have x minus 3 to the 1/4 equals 2. Raise them each to the 4th power. X minus 3 equals 2 to the 4th, or x minus 3 equals 16, and x equals 19. Great.